this is Cody Rice, and the language that I chose for this assignment is the Go programming language. So I've here my part 2 program, the common project. This reads a grayscale PGM image and converts it to a black and white PBM image using a threshold. And we can go ahead and demonstrate this right away. You can see we have the Desert Clouds PGM file in the project folder. So I'll go ahead and demonstrate this. So we'll do a go run main.go desert clouds.pgm. And here's the output. You can see the thresholds found here, and the PBM file has been written. So you can take a look at what it physically looks like here. There's the original PGM and the written PBM here. And we will go ahead and show this on an online PBM image viewer that I found. I've already got it pulled up here, Desert Clouds PBM. Go ahead and open that, and we have our image. So that's working appropriately. And we can also see, for the second image, I'm just using the PGM that was provided in the assignment spec. Just another PGM image that I had handy. So I have it here as input.pgm. It's just a square on a gray background. So I'll go and run that as well. Go run main.go input.pgm. And there we go, thresholds found, and we've got it written there. There we have our PBM file, as you can see. And I'll go ahead and pick it out here, input.pbm. And this is the scaled image, which is actually correct. I double checked. That's what it is supposed to look like. And so, yeah, that shows that everything's working appropriately for this project. Thanks a lot. So for part 3, I built a concurrent photo style analyzer in Go. This program looks at real photos and tries to guess whether each photo is analog or digital. So I chose this idea because I've recently been getting into film photography, and I thought it would be interesting to see if I could detect those visual differences with code. And I also chose this project because Go is strong with concurrency, which I'll demonstrate later how I applied it to this project. So instead of processing every image one at a time, I used Go routines and channels to analyze multiple photos at the same time. And you can see the folder structure here. It's simple. I just have photos with analog photos that I downloaded 35mm analog photographs online. And I have digital photographs, and these are photos that I took myself with my iPhone. And so the program reads photos from this folder. The folder name gives the actual label. So images in analog are labeled analog, and images in digital are labeled digital. And now I'll go ahead and demonstrate running this. All right, so I'll get into explaining what's happening here. So each image gets analyzed and printed with its actual label, the program's guess, confidence score, and the feature values. The main features are brightness, contrast, grains, sharpness, shadows, and highlights. And at the end, the program prints total accuracy, average feature scores for analog and digital photos, and the images it misclassified, which we have down here. So going back to the code, I'll start showcasing some of this. So we'll go to, this function analyze photo. So this function is where an image gets processed. It opens the file, decodes the JPEG, and converts it to grayscale pixels then calculates all the feature scores. And I'll show fine brightness. And yeah, so brightness is the average pixel value. Contrast measures how to spread out the pixel values are, which I calculated here. Grain looks at changes between neighboring pixels. Sharpness uses squared changes, so stronger edges count more. Shadows and highlights measure what percent of the image is very dark or very bright. And now I'll show the classifier. So here you have the function guess photo type. This is a classifier. It uses a simple weighted scoring system. Each feature adds points towards analog or digital. Whichever score is higher becomes the guess, and the confidence comes from how much of the total score went toward that guess. So I improved this by testing the output and looking at which images were misclassified. For example, I noticed shadows and highlights helped separate the data sets, so I added those features and adjusted the weights. The final accuracy is around 76% on my current data set. That might not sound like a lot, but I put a lot of work into getting it to a level that I was happy with. 76% is considered pretty successful, I think, in a project like this. And yeah, I'm happy with that level, honestly, with the amount of work I put in here. So I'm gonna scroll to main now, showcase a little bit more of what's happening here. So this is really where the concurrency is happening. This is the main Go feature I wanted to show. I created a jobs channel and a results channel. The main function sends photo jobs into the jobs channel, and workers send completed results back through the results channel. And I can scroll the worker here. So each worker is a Go routine. It loops over the jobs channel, analyzes one photo, and sends the result back. So since I start 4 workers up to 4 images can be processed at the same time. So that's concurrency for you. This made the project a good fit for Go because Go routines and channels are built directly into the language. And as far as documentation, this is all according to the very detailed project documentation on the course website. I tried to follow that to a T. So everything should be in order here in terms of documentation throughout the file. So yeah, overall this project helped me understand Go's concurrency model better, especially how Go routines and channels work together. It also helped me practice building a program from real data, testing it, and improving it based on the results. So that about sums up this project. I had a good time with this, and I'm really happy with how it turned out. So thank you.